All right, now we're talking about natural circulation. This is an important topic for all boiling water reactor operators to know, understand, and truly appreciate, because there will come a time in your career where you're relying on this to remove decay heat, specifically on a loss of offsite power, potentially for a moment while you're recovering forced flow. We're going to rely on some natural circulation. And let's look at what natural circulation is just simply. I'll set this to the side. And if I had two bodies of water, this being hot and this being cold, and they're just separated right here by a wall, and that they're allowed to flow. So what would happen is cold water is dense, and so it's going to tend to want to fall. So that would tend to cause flow in that direction. Once again, hot water, it's less dense, and it's going to tend to rise, and it's going to tend to cause flow in that direction. And you can see how we could create a circulatory path here of flow. Well, how would I promote this, and what is actually needed to get this flow going? Well, there's three things that are required. First of all, I have to have a difference in temperature between two bodies of water. That's a difference in density, so that one will rise and one will fall. Got to be a temperature difference. Number two, you have to have an elevation difference. The heat source has to be at a lower elevation than the heat sink. So you want the source and the sink, heat sink being the cold water, heat source being the hot water. You want a difference in elevation, where elevation will be Z. And finally, number three, they have to be able to communicate with one another. They have to be able to communicate. If I lowered this level right here too far from the hot and the cold, they can't communicate. This would just produce steam, and I would be relying on some condensing action. So to promote this, it's always best to have water levels high, so they're right up there, and it actually enhances the communication path with this higher water levels. Higher water levels here as well. All right, so if you're reading along on this page, it actually shows us the internal flow path of a boiling water reactor. We have our CRD mechs down here with the control rod guide tubes, jet pumps. Then I have the inner core area here and the downcomer water here. Well, that's where our cold and hot water sources are. Our cool water is out in the downcomer, and our warm water is in the core, the barrel region. It's going to tend to rise here. This is going to want to rise, and you see that. And then the water flow here in the cold path and the downcomer is going to want to fall. And the communication is from the dryers and separators here returning water. The warm water that comes this way will be separated and end up back in the downcomer. So to enhance this, if you ever are relying on natural circ, say on a loss of offsite power, and you have a form of injection to get water in, it's always best to increase water level to the steam separator turnaround point. Increase water level if you can. And what that does is enhances communication between these two sources of water, the heat source here and the heat sink here. Causes of natural circ. Right down here, causes of natural circ. It's a knowledge requirement. The note, in a boiling water reactor, natural circ is enhanced by raising water level to the steam separator point. Very important that you understand that. That'll actually be in your procedures. So when you get to the simulator, look that procedure up.